Okay, so moving on to our second application of De Mor's theorem. De Mor's theorem can be used to take a compound trig function like this one and actually convert it into a polynomial where all the terms are just basically functions of cos theta only. So basically we can combine that later on with substitution to turn something like this into something resembling a polynomial, but we'll get to that later. At the moment I'm just going to show you how to do it. Okay, so what we do is we start not with this, but by looking at this instead. Cos 5 theta plus I sine 5 theta. Okay, now obviously these two things are not the same. All right, I'm not pretending otherwise. The reason why I'm writing this out is because now that it looks like this, I can apply De Mor's theorem. Because I know that this here is going to be the same as cos theta plus I sine theta to the power of 5. So basically it's working the other way with De Mor's theorem. And the reason why this is significant is because actually I know how to expand this. Alright, so just looking at that right hand side, I know that this is going to be cos to the 5. Now I'm just going to abbreviate C5. Right, that means cos theta to the 5. So no compound angles in there, right? So C to the 5 plus, well the next thing, by binomial expansion, it would be 5, choose 1. Which we'll put those coefficients in a minute. I'm going to take these straight from Pascal's triangle, all right? Times cos to the 4, but the last term would be times sine, I sine theta. Okay, so actually I'm going to put an I there. Okay, second term, or third term I should say, will be, well, hang on. I'll leave that as a plus for the moment. So 5 choose 2, C3, S squared. Now there won't be any complex part to this because we got this term here squared, well actually minus I squared is minus 1, so that just has the effect of turning this into a minus. Okay. Next thing, well, okay, well, if that's a minus, then the next one would be a minus because I'm going to be cubing this, all right? But it'd be minus 5 choose 3 times I c to the c squared s cubed. And then the next term will be back to positive again because I to the power 4 is 1. So plus 5 choose 4. No i's, so c s to the 4. And then the last bit will be plus, well 5 choose 5 is just 1. So it'll just be s to the 5, but that's going to be another I in there as well. Okay, so the reason why I've done it like this is because now look, comparing this expansion to this, we can equate real and imaginary parts. So we've got the complex part which belongs to sine, the imaginary part belongs, sorry, the real part belongs to cos. So cos 5 theta is actually equal to c to the 5. I don't have to worry about this bit because it's got a complex part in it. So minus 5 choose 2 c cubed s squared. I don't have to worry about that bit either for the same reason that it's got a complex element. Plus 5 choose 4 c s to the 4. And I don't have to worry about that last part either. Okay, so the same method could be used to split sine up as well, except then you'd equate imaginary parts. Alright, well next, well this is already in terms of cos. We need to get our coefficients. Now, I'm quite lazy, I tend to go back to Pascal's triangle. So I know 1, 3, 3, 1, 1, 4, 6, 4, 1, 1, 5, 10, 10, 5, 1. So that's the row I want. So we've got cos to the 5 theta is equal to cos to the 5 minus 10 cos cubed. Now for the sine squared, I don't want sine squared, so I'm going to write that as 1 minus cos squared plus 5 c, and again 1 minus c squared all squared. Well, now it's just going to be a case of tidying up. So let's make sure you can still see that. So we've got cos to the 5 theta is c to the 5 minus, well, 10 c cubed plus 10 c to the 5 by expanding this bracket plus, well, 5c, I'm going to expand this bracket on its own first. That'd be 1 minus 2c squared plus c to the 4. Alright. Well, let's go for equating the c to the 5s now. So we've got to be quite careful to count them all. So we've got c squared, sorry, c to the 5 plus 10c to the 5, that gives us 11c to the 5. Now I'm going to get another one here. Okay, so 5c times c to the 4 would be 5c to the 5. So 1, that'll make 11, so that'd be 16c to the 5. That's that taken care of, that taken care of, and that bit taken care of. Now we're going to use c cubes. So we've got minus 10 here, and we're going to get another minus 10 here. So that's minus 20 c cubed. And then finally, the last little bit, plus 5c. Okay, so then we'll just write that out properly in full. That's 16 cos to the 5 theta minus 20 cos cubed theta plus 5 cos theta. And that concludes our proof.